Ayan. So let us do some review. Click follow. So here, XS, ang pangit ng S, ganyan na lang, is a measurable space. So pag sinabing measurable space, yung XS, meaning X is a non-empty set, and S is a sigma algebra on the space X or on the set X. Okay, so the elements of the collection S of subsets of X are the ones which are treated to be S measurable. No, yun yung mga sets na measurable, yung mga nasa S. Kung nilalagay natin sa S, yung mga tinuturing nating mga measurable na sets. Normally, they will form. Gusto natin yung mga measurable sets na to, they form a sigma algebra. Then, you get a function f from x to r. So, real value dito, although the domain may not contain numbers at all. No, it's an arbitrary set. This is said to be S measurable. So this is the term. If the condition is that the inverse image of B must be or must remain in S or must be S measurable for every, ano ba yung B na yan? Borel subset of, B of the real number line. So what we really mean by S measurable is that kung lahat ng mga Borel subset ng R, kinuha mo yung inverse image at yung inverse image was found in S, in other words, it's S measurable. If we can do that for every Borel set B, then that's the time we can say that F is S measurable. But you see, ang ating comment, no, this definition is really hard to use kasi first of all, it is not actually or practically possible to test all the Borel subsets of R, no? And then get the inverse image and check if it's an element of S, because normally there are a lot of Borel subsets of R. We know that, no? We know that as a fact. Napakaraming Borel subset ng R. In fact, almost all the sets that we were accustomed to simula nung elementary mathematics, they are all Borel sets, no? Parang hindi kayo nakakita ever ng set na Borel. Although in this subject, we have exhibited sets which are not Borel, no? Pero these sets are only known to exist, but basically we don't know kung ano talagang itsura nila. Basta certain tayo or mathematically they exist, but kung how do they look like, we don't really know, no? Okay. It turned out that we can simplify this definition. When you say simplify, there is an equivalent way to say whether F is S measurable or not, no? And this is more convenient because you don't have to check for every, you don't have to check this property for every Borel subset of R. You just need to know the following. So si F is S measurable if and only if. So the condition is that that the inverse image of every interval of the form, no, ganyan na lang, is in S for every A in R. Aha. Now, so very well, and this is easier to use because you just need to consider all the things or all the intervals from a to infinity for any a, no, where a is a real number, kailangan i-check mo na lang if the inverse image of this interval belongs to the collection S or is S measurable. At least, you know kung ano yung mga tinetest mo. Hindi ka gaya na ito for a general Borel set that is very hard to picture out. Again, no, kapag itong set na ito, kapag in-expand mo to, it contains all x whose image are greater than a. Kasi inverse image nung interval from a to infinity. Lahat ng mga f of x na nasa interval na yan are greater than a. Okay? Sometimes sa probability theory, no, sabi ko nga, we sometimes prefer this notation instead. Kasi yung mga S measurable na yun yung mga random variables nyo nung when you were a little younger, studying them in probability theory. Now there are what do you call this? Important situations. Let me write here important scenarios where we are really interested in, you know, kapag yung XIR, let's say F is X measurable. Okay. Kapag ang XIR,
Papa, sino motor gamit mo kasi? Kay Charita. Wala mo rin na may mga balay.
paki-mute yung mga microphones nyo. Okay. Kung ang domain natin ay pipiliin natin to be not necessarily R, but somehow it's a subset of R. Sabihin, mga real numbers na ang laman ng X. At yung S natin ay pipiliin natin yung mga Borel sets din, no? This is the for ano, bigyan ko lang ng reference, Borel sigma algebra. Kung yung S ay gagawin nating Borel sigma algebra, in short, yung collection of Borel sets din ang laman ng S, paano nagbabago itong definition? So, the inverse image of every Borel set is also Borel. Kapag ganun yung nangyari, no? We say that F is Borel measurable. Ito yung ginagamit nating term. So, kapag sinabi ni Sir na ang function ay Borel measurable, ang meaning nun, yung inverse image ng every Borel set is also Borel. Or you can use this criteria. The inverse image of every interval of this form is Borel. No, yun lang yung requirement. Kung ang X naman ay same, no? Kapag kinuha mo siya sa real number line, and you take the sigma algebra S to be the sigma algebra M, which contains the Lebesgue measurable sets. Ito yung pinag-aralan natin ng mahabang panahon before, no? Paano maka-classify ng isang subset ng R to be Lebesgue measurable. Si F tinatawag nating Lebesgue measurable. So paano magka-qualify ang function to be Lebesgue measurable? Kailangan ng inverse image ng bawat Borel set ay Lebesgue measurable. Now, as you can see, mas maluwag yung requirement na ito kesa dito. In fact, lahat ng mga Borel measurable sets ay Lebesgue measurable. It is because lahat ng Borel sets ay Lebesgue measurable. Pero remember, hindi lahat ng Lebesgue measurable sets ay Borel sets. Therefore, hindi lahat ng Lebesgue measurable na functions ay magiging Borel measurable. Okay? So, basically, ano ba mga itsura ng mga measurable functions? Well, meron tayong remark last time. Sabi natin, if the sigma algebra S is selected to be the power set of X, kapag power set, ibig sabihin, you are allowing or you are regarding every subset of X to be measurable. Kung ganon, maluwag yung space na ito. Ibig sabihin, almost lahat ng subset niya ay measurable. Mag-follow na lahat ng functions ay measurable. Did you understand? Lahat ng function from X will be measurable. In the extreme end of the situation, in the other end, kung yung S naman is taken to be the strictest sigma algebra, which contains only the empty set and X, yan lang yung if yung dalawang sets lang na ito ang tinuturing yung measurable, no? Then the only functions which will qualify as S measurable are the constant functions. Kaya nga, ang constant function regardless of the sigma algebra, it will always be S measurable. It will always be measurable. Did you understand? Sila yung mga pinaka-basic na examples. So for today, we are going to expand our library of measurable functions. Paano ba magkaroon, ano-ano ba yung mga examples ng measurable functions maliban sa mga constant functions? Especially kung let's say, ang S natin ay yung Borel sigma algebra o yung Lebesgue sigma algebra kasi these are the sigma algebra that we are interested in real analysis. No? Pag ikaw ay nasa real analysis, normally, we confine ourselves with these two. But of course, we're speaking of measure in general, kaya we sometimes speak in general. Okay, another example. Actually, ano pa? Ayan, so here, X is a subset of R. Okay? Then according to this example, lahat ng mga continuous functions from X to R, ito yung mga kauna-unahang class ng function sa calculus na naaral nyo, no? When you were, lahat ng student ng calculus, alam kung anong ibig sabihin ng continuous. Okay? Lahat ng mga continuous functions mo from X to R are actually Borel measurable. Dahil Borel measurable siya, ibig sabihin magka-follow na siya ay Lebesgue measurable. Question: why would a continuous function from X to R be Borel measurable? Ano nga ibig sabihin ng Borel measurable? Sir, kailangan ang inverse image ng bawat Borel set ay Borel. Pero sabi ko nga, you don't need to check for every Borel set. No, you just need to check the inverse image of intervals of the form a to infinity. Yan na lang ang kailangan mong i-check. Now, alam nyo kasi, ang mga continuous functions, meron silang nice property when it comes to, may ginagawa sila, particularly sa mga open sets ng space. No? Let me write here as a note. If X is a subset of R and F is continuous, then for every open subset of R, call it U, kung si U ay open, then we have, one has that the inverse image of U is open in X. Kapag ang function kasi continuous, no, pag ang function continuous, meron siyang property na kapag kumuha ka ng kahit na anong open set and you take the inverse image of the open set with respect to the function, the resulting set will still be open in the domain, which is X. Do you understand? Kumbaga, ang inverse image ng mga open sets ay open. Actually, hindi lang ito if then this is a complete characterization of being continuous. Kumbaga, if you want to write continuity, or if you want to state continuity using open sets only, without reference to epsilon delta, if you don't want to use the epsilon delta definition, you can use open sets to characterize continuous functions. At ito yung characterization. Kung hindi nyo naaalala yung theorem na ito, of course, I will not do the proof here kasi this is a thing from advanced calculus na dapat na-establish nyo na noon. Okay? So here's the idea. If you take an arbitrary real number, so normally, proof of measurability, nag-start dito, let A be a real number. Tapos i-check mo yung inverse image ng interval, open interval from A to infinity. Kailangan yung inverse image nun nasa loob ng sigma algebra na concern natin. In this case, yung Borel sigma algebra. Correct? The thing is, if you take the interval from A to infinity, this interval is open. Right? This is an open set. Oh. Dahil kung nga si F is continuous, anong magiging conclusion? Since F is continuous, then the inverse image of the interval from A to infinity is also open in X. Hence, Borel. Kasi lahat ng open sets, lahat ng open sets kasi ay Borel sets. In fact, ang mga open sets ang bumubuo sa Borel sets. Borel sets are combinations of open sets using countable unions, intersection, complements, etc. Mga set operations na yan. Therefore, because this is true, therefore, we can now conclude that F is Borel measurable. Ngayon, kaya nga nasabi ko, ang mga Borel sets kasi ay Lebesgue measurable din. So it is always possible to conclude that F is also Lebesgue measurable. Okay? So do you understand this? Lahat ng function na continuous, lahat ng function na continuous na napag-aralan nyo sa calculus, kahit na ano ang domain, as long as it's continuous there, it is Borel measurable. Okay? And more generally, Lebesgue measurable siya. Alright? Next. Now, the function need not be continuous at all, for it to be Borel measurable. In fact, basta yung function strictly increasing kahit na putol-putol, okay, strictly decreasing, Borel measurable din siya. You know why? Sige nga, why? Anybody in the group knows the answer to this question? Bakit Borel measurable ang mga strictly increasing function? For example, let me draw a strictly increasing function. Kunwari, ganito siya. Ayan, katulad nito, may discontinuity. Pero dahil siya strictly increasing, ang x natin dyan, ito. Ito yung x natin. Ayan. Ito si F. Bakit siya Borel measurable? Sino nakakaalam? So, di ba sabi ko, ang start ng proof, or lagi nyo titignan, ang start lagi ito, let A be a real number. You have to show that the inverse image of the open interval from A to infinity is what? Is what? Is a Borel set, right? The thing is, kapag kasi strictly increasing yung or increasing na lang ha, kasi pares lang naman yung magiging result kapag decreasing. Let's say, kumuha ka ng A, halimbawa ito yung A. Let's say I take this as my A. Yan. Yung interval from A to infinity, ito yan, pataas yan. If I take the inverse image of that, when you say inverse image, alamin mo yung lahat ng mga x kung saan ang f of x greater than A. So, nasan yun? So, parang shadean mo itong portion na ito. Ano-ano yung mga x, no? Kung saan ang f of x ay greater than A. Mapapansin nyo, ito siya. No? Itong mula dito, open yan ha, hanggang dun. No? Ito yung f inverse of A to infinity. As you can see, kahit paano ko i-move si A, taas or pababa, no? As you can see, yung inverse image niya is always what? Note that since f is strictly increasing na lang ha, yung decreasing parehas lang yung proof. Then, property to ng mga strictly increasing kasi yung f inverse ng A to infinity is what? It is basically a union of intervals. Is a countable union of intervals. Okay? Halimbawa, kung yung A mo nandito, bakit union of intervals? Hindi ba intervals? Di ba ito example mo sa interval yung inverse? Yes. Kasi yun nga na kasi pag ililipat mo yung A somewhere else, let's say nandito yung A sa baba, ang inverse image mo, union ng dalawang actually interval kahit na nasaan si A, no? Yeah, actually interval. So, huwag na natin sabihin countable union of interval. Interval pala. Napaisip din ako bigla. Is an interval all the time. Kasi nga, strictly increasing. Hence, Borel. Lahat kasi ng mga intervals ay Borel sets. So, tapos na. Do you have a question so far? Do you have questions so far? Before I proceed. Meron man tanong? Walang sumasagot. Ayan, may sumagot. O, wala kayong tanong so far. Okay? The next example will show us that if you have two Lebesgue measurable functions, their composition need not be a Lebesgue measurable function. To do that, ang gagawin nyo, we will consider this function psi. Naalala niyo yung function na psi na ito from last lecture. Yung psi of x is the sum of x and phi of x, where phi of x is the devil's staircase function or the Lebesgue-Cantor function. Ang property nito, ito is strictly increasing if you can remember. So based on the previous example, this must be Lebesgue measurable, right? Actually, Borel measurable to be more specific. Ayan. In fact, it's not only strictly increasing, it's continuous and bijective. So wala ka na masasabi dyan. Talagang walang kaduda-duda, siya ay Lebesgue measurable. Ang maganda dito, dahil siya ay continuous and bijective, yung inverse niya will also be continuous and bijective. Meron siyang inverse na function. Ito yung inverse niya. So dahil continuous yung inverse niya is also Borel measurable, hence Lebesgue measurable. If you can remember, we proved this last time. This function psi maps a Lebesgue measurable. Lagay ko dito ha. Nakakalimutan ko kasi minsan isulat. This function psi, it maps a Lebesgue measurable set M to a non-measurable set N. Merong part, in fact, yung M dito is found as a subset of the Cantor set. naging measurable yung M kasi yung M na yun, yung na-produce natin from previous lecture, is found as a subset of the Cantor set. Eh, ang Cantor set measures 0, Lebesgue measures 0. Kaya lahat ng subset niya, Lebesgue measure 0. Eh, under the Lebesgue measure, ang lahat ng sets na ang measure ay 0 ay Lebesgue measurable. If you can remember all of those. Ang idea dito, yung function na ito, it turns a Lebesgue measurable set M to a non-measurable set N. Nakahanap tayo nito last time. Okay? Hindi ko na isusulat kung ano yung M at N na ito, basta they are exactly the M and N that we have discussed in the previous lecture. Sabi natin nung nakaraan, M can't be Borel. Kasi alam nyo bakit? If M is a Borel set, dahil ito'y continuous at bijective, yung image ng Borel set dito, magiging Borel set din dito. So, mangyari, magiging Borel set yung N kung si M ay Borel. But N is not measurable. Therefore, it can't be Borel. Kaya dapat si M, hindi dapat Borel set. Si M yung example natin ng measurable naman, pero hindi siya Borel set, if you can recall. Okay? This is what we do. We will consider the composition of chi M. Anong chi M? Yung chi M is the characteristic function on the set M. Dalawa lang ang value nito. 1 if x is in M, and 0 if x is not found in M. Yung function na to ay characteristic function. As long as the set M is measurable, this is measurable. Sabi ng previous example natin. Saan ko kinuha yung example na yun? Let me find that for you so you can take a look. Ito yun, no? Yung nakaraang example. No? Sabi natin dito, mga characteristic functions ay S measurable. Basta yung set E na kino-consider ay measurable. Excuse me. Nasaan ba tayo? There. Okay, so measurable to. Ito ay measurable kasi nga siya ay Lebesgue measurable, I mean. Kasi siya ay continuous. Alright. Pwede ko bang kunin yung composition talaga? Pwede naman kasi pag composition, tatandaan nyo, nauunang gumana yung kanan. Yung psi inverse kasi, it maps 0, 2, 2, 0, 1. Tapos, yung chi M, it will map 0, 1 to, well, just 0, 1. No? Ganyan. Dalawa lang ang values niya, 0 at 1. Ito yung composition ni chi M tsaka psi inverse. Okay, let's continue. I will do this. I want to show that this is not Lebesgue measurable at all by doing the following. I'm going to take the singleton containing 1. You know that singletons are Borel measurable. Okay? This is Borel measurable. This is a Borel set. Okay? I will take the inverse image of the singleton with respect to this with respect to that composition. But do you recall kapag meron kang F circle G, ang inverse image ng, let's say, E under this is G inverse of F inverse of E. Property yan. Magiging ganyan. Magiging psi of chi M inverse of singleton 1. Okay? So, nanggaling ulit? So, nanggaling siya sa property na ito. If you get a set E, nagiging F inverse of, nagre-reverse yung order. Okay? Alright. So, ang tanong, anong inverse image ng 1, ng singleton 1 under the characteristic function or ano tong set na ito? Babalikan mo yung definition. May sabihin na inverse image ng 1. Sabihin na ito, lahat ito, remember, ang domain ng chi-m ay 0, 1. Okay? Lahat ito ng mga points sa 0, 1, sa close interval 0, 1, na ang image ay equal sa 1. Kasi yun lang ang laman ng set. Characteristic function to eh. So definitely, ang mga nagpupunta sa 1 ay yung mga nasa M. Pag wala ka sa M, 0 ka. Ang gusto natin inverse image ng singleton na 1. Kaya, ang inverse image ng 1 ay yung M mismo. Kasi yung mga nasa M, ang exactly may image na value ay 1. But, what is now the image of M under psi? Sabi natin kanina, it maps a measurable set M, the set M to the non-measurable set N. So that's N. The thing is, yung N dito, hindi siya Lebesgue measurable. Na? It's not Lebesgue measurable. So therefore, this function that we were able to construct is not Lebesgue measurable, even though the component functions are both Lebesgue measurable. So remember ha, pag may composition ka ng dalawang Lebesgue measurable function, hindi guaranteed ang pagiging measurable. Okay? Excuse me. But we have actually a theorem kailan nagiging measurable ang isang composition. Na yun naman ang maganda. Ito yung ating theorem. Look at this. So, si XS ay measurable space. Si F ay S measurable. Okay, so si F ay S measurable. Okay. If Y is a subset of R, no? And I have a function G from Y to R, no? That is continuous. So that ang image ng X under F ay nasa loob ng Y. Yung composition na ito, no, is S measurable. So let me draw the diagram for you so you can see. No? G circle F. So ang unang gumagana si F. Ito si X. Ito si R. So this mapping is the F. Anong alam natin kay F? Measurable. Okay? Then, kaya natin gusto ng image ng X ay nasa loob ng Y. No? Ito. Kaya natin ito gusto para kung ano man yung magiging image ng F, kakainin nyo ng Y, ng G, sorry. Kakainin nyo ng G. Kasi ito may subset ito na Y, tapos nasa loob ng Y yung F of X, no? Para kung ano man yung output ng X, ganito na lang, para mas maganda yung diagram, susulat ko ng F of X, right? Kaya ako gustong yung F of X na nasa loob ng Y, no? So that yung F of X na yan can be placed inside Y. Lahat ng ibubuga ng F, kayang lununin nung G. Do you get me? Do you get me? So ito yung function na G. Itong property ng G, continuous. So nasaan yung composition? Yung composition ay ito. Yung composition siya ay nagsasummarize ng action ng dalawa. Okay? Oh. So kung tatagalugin ko to, what does this say? This says that if you compose a measurable function with a continuous function, meron tayong direction ha. If you apply a continuous function to a measurable function, the result is measurable. Do you understand me? Bakit yung kanina, sir, continuous naman yung isa pero hindi naging measurable? Kasi dito, ang continuous kasi ito hindi ito necessarily continuous. Okay? Kailangan ito yung continuous, ito yung measurable. Baligtad. Right? Yun. So why is that? This is the reason. Pag kumuha kasi ng Borel set, kahit na dahil si G ay continuous, ang inverse image ng B ay Borel din. Bakit? Ang inverse image kasi ng mga open sets ay open. Ang mga Borel sets, binubuo lang naman ng mga open sets. Thus, if you take the inverse image of B under the composition G circle F, it's going to be F inverse of G inverse of B. So this is the idea. Ito kasi ay, si B kasi Borel. So si G ay, anong katangian ni G? Si G ay continuous. So saan niya dadalhin yung, saan yung inverse image ng B? So this is also Borel. But F is what? Measurable. So anong inverse image ng Borel set? Borel pa rin. Ay, sorry. Hindi pala Borel measurable si F. Si F pala ay S measurable. Okay? So therefore, ito ay nasa S. O yun yung sinasabi kong S measurable. Because this happens for an arbitrary Borel set B, therefore we can now say that G circle F is S measurable. Well, sir, ano namang impact niyan? Ano bang mga example ng mga continuous function? Kasi ganito. Halimbawa kasi kapag ang kinuha kong g of x, kunwari x squared, o diba, this is a known continuous function in the real number line. No? This is continuous. Pag in-apply ko yan sa isang function na f, ang gagawin ng g circle f, i-square niya lang kung ano man yung binubuga ng f. Did you understand? So ito ay measurable. Pag daw nag-square ka ng isang measurable function, measurable pa rin. In fact, kahit na anong gawin mo sa isang measurable function, as long as the operation that you have performed is continuous pa rin yung lalabas na sagot. Halimbawa, ano pa? Halimbawa, ang g of x na kinuha ko, sin x. Okay, ito, well-known continuous function yan sa analysis, di ba? Ang G circle F mo ngayon, sin of F. Measurable pa rin yan. Naintindihan nyo? Ang ginagawa kasi natin, pinaparami natin yung mga examples natin ng mga measurable functions. Did you understand? O, pwedeng ang kunin mo for example, yung absolute value ni X. Continuous din yan. When you do G circle F, it's going to be the absolute value of F. Measurable din daw yan. Basta si F ay measurable. Ang sinasabi ko dito, ito, yan o, example. Halimbawa, you have an S measurable function F with domain X. Marami kang magagawang measurable function pa out of F. Ang gawin mo, you can take the square, you can take the absolute value, you can multiply a constant. Na kasi, kapag ang g of x mo, kunwari, ax, where a is an arbitrary constant, linear function yan, kaya yung continuous. So pag nag-multiply tayo ng kahit na anong constant sa kahit na anong measurable function, measurable pa rin siya. Did you understand? Sin f, cosine f, whatever. Whatever ang gawin mo sa f, as long as continuous yun, the resulting function will still be measurable. So naintindihan ba si Sir? Naintindihan yung moral of the story? Huwag niyong pansinin yung details. Naintindihan yung idea. If you apply a continuous function to a measurable function, the resulting function is still measurable. Naintindihan si Sir? Okay. Tatandaan niyo yan ha. This is a very important result. Ayan na. How about, sir, yung other combinations ng mga function? Ano yung sabihin nyo ng other combinations? Yung F, yung G, wait lang. So let me address a question in the chat box. Sir, yung F and G po ba in this case can have the same variable? Anong ibig sabihin nun? Anong can have the same variable? Anong parehas ng X? Pwede nyo palitan. I mean kung X, kung F of X, G of X. Yung X naman kasi sa function, ito yung problema, no? Akala natin kapag function dapat laging X. Yung X doon pwede nyo palitan ng kahit na ano. Sanay lang tayo na X. Ang bida talaga sa function, yung sa F of X, ang function hindi yung F of X. Ang function doon yung F. Kaya nga tinawag na variable yung X kasi pwede mo siyang palitan ng kahit na ano. Sanay lang tayo na X yung ginagamit but hindi naman kailangang X yun. No? Pag nakakakita kayo sa math ng y equals f of x, no? Ito yung problema, no? Notational ano to eh. Tinatawag ng function yung f of x. In reality, yung f of x is not the function. It's the image of the function. No? F is not even the function. F is just the name of the function. Ito yung function. Ito yung pangalan ng function. Yung f of x, hindi. Pwede kong gawin yung z equals f of t. It doesn't matter. Sanay lang tayo. So we are just accustomed to using y is f of x or something sa calculus kasi. So kung pwede bang gamitan ng x yung f at g, why not? Oo, pwede. Walang, ano yun, walang kinalaman. Ang bida basta yung f at saka yung g. Okay? Okay, let's continue. So here we are now talking about the algebraic combinations of two measurable functions. Would they be measurable still? Halimbawa, inad mo, sinubtract mo, minultiply mo yung dalawang measurable functions. O kaya dinivide mo si f with by g. Would you get another measurable function? The answer is yes. For most of the interesting cases, yes. Bakit sinasabi ni Sir na for most of the interesting cases? Kasi sa division, meron tayong what you call this, provision. Syempre, ayaw natin yung pagkakataon na si g of x ay magsi-zero kasi nasa denominator siya. Okay? Actually, ang ipapakita ko lang dito, yung plus. Pag nagawa na natin yung plus, alam na natin yung lahat. Okay. We'll see. So, paano ba ito? So, wala palang proof ito, so I need to write. So, here, papakita natin si f plus g is as measurable. Okay? So, babalikan natin yung definition or you may want to use the theorem if you want. So, ang gagamitin ko yung may a, yung may interval from a to infinity. So, I will write let a be a real number. So, sa isip natin, anong kailangan nating mangyari? Ang kailangan mangyari dito, no? So, kailangan yung inverse image ng interval na ito under the sum. No? Kailangan yung inverse image nito dapat ito ay nasa S. Mapakita mo na nasa S. If you were able to show that for any A, okay lang, for all A ito, no? Yeah, we're done. Ganun lang naman magpakita ng measurability. Kaya lang, paano natin ipapakita yun? That's the idea. Paano masasabing nasa S? Eh wala naman tayong alam tungkol sa mga elements ng S. How are we going to show that it's there? No, we don't even know. Ganito. I'm going to rewrite this set. This is a set. No? Or I'm going to decompose this into simpler sets na alam kong nasa S. Okay? Kasi I know that F and G are both S measurable. So yung mga inverse images ng mga Borel sets ay, well, under F and G ay nandun sa S. Diba? Okay, so ganito. Dahil si A ay arbitrary real number, okay? Let's look at this. Kapag si X kinuha ko sa note, lagay ko note. Okay. So I'm going to consider the set F plus G inverse of the interval from A to infinity. Okay? Titingnan ko, ano yung mga nandito? Ano yung mga nandyan sa set na yan? So I'm going to take an arbitrary X. Okay? If I take an arbitrary X in this set, anong masasabi nyo kay X? Well, ang nandyan sa set na yan, sir, yung mga bagay na ang image ng F plus G ay nandun sa interval na A to infinity or those that are greater than A, right? Tama? Yan ang ibig sabihin kapag nandyan ka sa set na yan. Yung image under F plus G nung X ay greater than A. By definition, ano bang F plus G of X? By definition, that's the sum of F of X and G of X that's greater than A. So this is the trick. The trick is to put G of X on the right. Still correct, no? So in other words, these are two real numbers. These are real numbers. These are real numbers where this is strictly less than F of X. So in short, merong pagitan sa dalawa. May pagitan dito sa dalawa. Hindi sila equal. Now, may space sa gitna ng F of X tsaka ng A minus G of X. Anong gagawin ko? Mag-a-apply ako ng tinatawag na density theorem for real numbers or for the rational numbers. I mean, kung may space sa gitna nilang dalawa, di ba, we know that there is a rational number in between. Naku, paano naman napasok ng rational numbers? You will see why. Sure ako na merong rational numbers R, no? Such that yung R na yan ay nasa gitna nung dalawang nag-uumpugang bagay na yan. No? Yung R ay nasa gitna ng A minus G of X tsaka ng F of X. Okay. So ito, i-rewrite ko ulit. I'm just going to rewrite. Hahatiin ko to sa dalawang inequality. Yung unang inequality, that's equivalent to G of X is greater than A minus R. Yung pangalawang inequality naman, that's equivalent to writing F of X is greater than R. Nakuha niya bakit? Ito, nanggaling to dito. Nilagay ko sa kanan yung G of X, yung R sa kaliwa. Okay? Please consider rewriting. Okay? Then this inequality was obtained from the second inequality. Okay. Why would I want to write that in that manner? Ganito. Si X kasi, kapag si G of X ay greater than A minus R, nasan si X? Si X ay nasa inverse image ng interval from A minus R to infinity. Diba? At kapag naman ang F of X ay greater than R, nasan si X? Si X ay nasa inverse image ng R to infinity under F. Okay. Iko-convert na natin ngayon ito into sets. Ano yung sinasabi ni sir? I'm going to erase this one. Wait lang. Ito tayo. Okay. Therefore, ang inverse image ng a to infinity under f plus g is going to be, no? Kasi kapag si x nandito, si x ganito yung property na x and vice versa. So how would you write this as a set? Okay. Meron lang akong sigurong i-recall. Recall tayo ha. So you need to know all of this. Pag meron akong union ng maraming sets, ganyan. Anong mga nandyan sa loob ng set na yan? Ang mga nandyan, no? Paano mo masasabi na si x ay nandyan sa union? Nandyan si x sa union if there exists some alpha in A such that x is in x alpha. Yan ang meaning ng si x ay nandyan sa union. Kung merong isang index where x is found in one of the sets in the collection with that index. Did you understand? There exists. Pero kapag intersection, para mapunta ka sa intersection, ito, strict ito di ba? Ang kailangan for all alpha in A, kailangan sa bawat x alpha, present si x. Sa union, hindi masyadong strict. Kailangan lang mapunta ka sa isang alpha, x alpha. Pero pag intersection, you should be in every x alpha. That's the idea. If you're going to look at this, there exists an R in Q such that x is here. Sige nga, i-rewrite ko pa to even better. Pag ito kasi, pag ito, pinagsama mo, and ito ang end, remember, intersection yan. Kaya kapag ang x ay nandyan, si x ay nasa intersection ng G inverse of A minus R to infinity, intersection, F inverse R to infinity. Sa unahan, merong there exists an R in Q. How would you write the set? Ito siya. So this set is basically the union over all R in Q of the sets of the form ano itsura? G inverse of A minus R to infinity intersection F inverse of R to infinity. Ganyan ang itsura nung yan, ayusin ko. So yung there exist mo, na-convert yan sa union. Okay? Union ng mga nung mga ganitong klaseng sets. Okay, this is now the idea. Okay, move ko ulit dito. Ang kulit ko, Si F kasi, measurable. S measurable. So, ibig sabihin, ang inverse image ng mga intervals na ganito ang itsura, dapat nasa S. Okay? Ganun din naman ito. Ito rin ay interval na open from a particular number to infinity. Therefore, yung inverse image under G ng interval na yan, nasa S. Remember, si S ay sigma algebra. So, ang intersection ng dalawang bagay na nasa S ay nasa S. Kukunin mo yung union nila over all real rational number R. Ito na yung reason bakit gusto ko rational number ang kunin ko sa gitna. Kasi ilang rational numbers ba ang meron? Hindi masyadong marami. Countably infinite. So this remains as a countable union of elements in S because S is a sigma algebra, I know that the countable union is still an element of S. And this is what we wanted to happen in the first place. Diba? If you're going to think about this one, yung gusto natin mangyari. I was able to decompose this as a union, as a countable union of elements of S. Therefore, this is in S. And with that, we can now conclude that F plus G is S measurable. Okay ba? Ay, nangyari. Wait lang. Oh. How about, sir, yung F minus G? Paano yung F minus G? Well, ganito lang yan. Ang F minus G kasi is F plus negative 1 times G. Okay? Si G ay S measurable. Sabi natin nung nakaraang example, if you multiply a constant to an S measurable set, this is S measurable. No? Ang sum dalawang S measurable is S measurable. So this is S measurable. So tapos na tayo sa F minus G. Paano naman, sir, yung product? So this product is a tricky one, but you will see that you will find that this is nice. Yung product kasi na to may be written as follows. It can be written as 1/4. Oh my God, but may 1/4. It's 1/4 F plus G squared minus F minus G squared. So this is a brilliant way to write the product nicely. Can you please check if the algebra is correct? Kasi ganito yun eh. May F squared dito, may G squared. Meron din namang F squared dito, meron G squared. Magka-cancel yun pag sinubtract. Ang middle term nito, 2FG. Ang middle term nito ay minus 2FG. So if I subtract 2FG minus 2FG, I'm getting 4FG. Kaya may 1/4 dun to get FG. So this is brilliant, no? This is a brilliant way to rewrite the product. Okay? Okay. Ganito, si F and G are both S measurable. Sabi nung number 1, si F plus G, tsaka si F minus G, parehas S measurable. Sabi ko kanina, if you apply a continuous function on a measurable set, a measurable function, measurable pa rin. So if I take the squares, they remain measurable. So ang difference ng dalawang S measurable ay S measurable. And if I multiply another constant, it remains or it maintains its measurability. Therefore, this is S measurable. Did you understand? Nakuha nyo ba? Naintindihan nyo ba si Sel? Naintindihan nyo ako? Okay. How about F over G? Alam ba hindi nagsisiro si G? G of X, I mean. Bakit si F over G measurable? Ganito. Yung F over G kasi ay F times 1 over G. Okay. Si G ay measurable. Bakit measurable yung 1 over G? Kasi yung function, the function phi of t equals 1 over t. No? We know from calculus that this is continuous everywhere except at 0. So it's continuous anywhere as long as t is not 0. Okay? Ang graph nga nito, if you can remember, yung pag ganito, the only point where it is discontinuous is at 0. So yung 1 over t pala ay continuous everywhere as long as t is not 0. Si g naman, si g of x hindi naman nagsi-0. So if I take the composition of v with g, yung 1, dahil si v ay continuous, si g ay measurable, 1 over g will maintain its measurability. So kung measurable to, ang product ng dalawang measurable, sabi nung bullet number 2 is measurable. So at this point, marami na tayong examples ng mga measurable sets. Diba? Lahat ng mga continuous. Kahit pala hindi continuous, basta increasing. Diba? Pangalawa, kumuha ka ng kahit na anong dalawang measurable, i-add mo yung mga, let's say, kumuha ka ng mga characteristic functions, i-add mo, i-subtract, multiply, i-divide, no? As long as the rules are satisfied, then you're okay. Meron ba tayo sir example ng hindi measurable? Meron kanina, di ba? Meron tayong example ng hindi measurable na function. Okay. So ito na, tungkol naman ito sa mga sequences of functions. Kagaya dati, if you can remember at the beginning of this class, no? We normally have a sequence of functions, then it will converge to a certain function. Kung yung mga elements ng sequence mo has a certain property, we would like to know if the limit also has that property. In this case, we're talking about measurability. So sabi ng theorem na ito, if Fn is a sequence of S measurable real valued functions on X, lahat ito measurable. At kung nagko-converge si Fn to F pointwise on X, then the pointwise limit F is also measurable. So to state this alternatively, you can say that the pointwise limit of a sequence of measurable functions is also measurable. Kumbaga, if your function was constructed by using a sequence of functions, measurable functions, which are all measurable, then your function is also measurable. Intindihan nyo? In fact, hindi nyo na kinailangan ng uniform convergence. As long as the convergence is pointwise, okay na yun. Na-maintain na yung measurability. Did you understand me? Okay, bakit sir? Okay, ito na naman tayo. Excuse me ha. May COVID yata. Hindi ko alam kung ano to. Wait lang. Okay. Bakit ulit si S ay measurable? So this is what we do. Let A be a real number. So what do we need to show? We need to show that the inverse image of A to infinity is what? Is in S. Okay. Hindi ko na sinusulat yung is kasi normally ganito ko sinusulat, di ba? The inverse image of the interval from A to automatic yan, hindi ko na isusulat yung dalawang parenthesis kasi sayang yung tinta. Okay? So we understand what this means, okay? It's the inverse image of the entire interval. So here you go. Pag kasi si x ay pag si x ay nandito sa inverse image na yan, gaya ng sabi ko palagi, that means to say, si f of x ay greater than a. So which means f of x minus a is greater than 0. Okay? By the Archimedean property, this is what I do. Meron kang makukuhang natural number na n. I'm not going to use n. There is going to be a natural number m. such that 1 over m is less than f of x minus a. So kahit gaano kaliit yung f of x minus a, because it is positive, some 1 over m or some number of the form 1 over m will be smaller than f of x minus a. Tama ba? Ang tawag na dito when you were younger is the Archimedean property. One of the versions, maraming versions ng Archimedean property, and this is one way to write it. Okay? So what's next? So in this case, i-rewrite ko lang ulit. There exists m in n such that si f of x, paano ba? Si f of x, i-isolate ko f of x is greater than a plus 1 over m. Naka-isolate lang. Okay? Since okay, papaliwanag ko dito ha. Kasi gusto kong gumamit ng puro arrows lang. Wag yan. I'm going to write a comment here. Since f, ano bang magandang letter? N, no? Okay. Since fn of x converges to f of x. Ba't nagko-converge yan? Kasi nga kahit na nasaan yung x na yan, point-wise kasi ang convergence, yung fn of x nagko-converge sa f of x. What does this mean? This means that there will exist a natural number n now such that fn of x is greater than a plus 1 over m for all n greater than or equal to n. Kasi ganito. The idea is that yung limit mo, ito yung limit mo nasa kanan ng a plus 1 over m. Kung nagko-converge ka sa f of x, yung mga terms ng sequence na ito, yung mga terms ng sequence na ito will eventually fall to the right of this. Kumbaga, ganito ha. Ito kunwari sa a plus 1 over m. Ito si f of x. If you really converge to f of x, eventually, hindi ko sinasabing for all n, no? Eventually, yung fn of x mo, mas malaki na sa a plus 1 over n kasi lumalapit ka doon sa f of x. Did you understand me? Did you understand me? Di ba? Eventually, we can say that fn of x will be greater than a plus 1 over m. That's the idea. When you say eventually, after some index, or there will be some index wherein for all index after that, ito ay totoo na. Alright. So let me continue. I'm just going to rewrite this once again. There exists. So kulang na, no? Hindi ko na naisulat yung, ano nangyari? Hindi ko na naisulat ito. Kopyahin ko itong portion na to. Importante yan, di ba? Wait lang. Copy. Paste ko siya dito. There. Wait lang. Ayusin ko lang yung aking there. Yeah. Okay? Okay ba? Okay. So ito siya. There exists m in n. There exists a natural number n. What else? In n ulit, no? And such that for all n greater than n, anong true? Itong true. But you know, I can rewrite this more nicely. Ganito, si x nasa inverse image ng a plus 1 over m to infinity under Fn. Fn. So do you agree? Do you agree? Actually, lahat pala ito pwede nating ibalik. If and only if yan. Kalimutan ko lang isulat. So, question. Using this equivalence, how do you now express this in terms of the simpler sets? Ganito siya. Therefore, yung F inverse of A to infinity is basically what? The union. Kasi not union, kasi there exists. The union over all M, okay, of the union over all N, okay, of the intersection from N to infinity, kasi N greater than or equal to N, of these inverse images. Yeah. So this is what we have. That is what we have obtained. And why is this nice? The reason, ulit ha, itong for all na-convert sa intersection. Itong there exists na-convert sa union. Itong there exists na-convert sa union. So that's how it works. Ay, may kulang. And ito. Lahat kasi ng Fn, ano yung sabi natin? Each Fn is measurable. So dapat yung inverse image ng interval na to ay nasa S. Naintindihan nyo? Yung inverse image na nasa S. So, ang intersection, lahat ito ay countable intersection, countable union, right? So, a countable combination of elements of S will still be in S. Nasa S yan. Kahit na ano yung A. So, what does that show? It shows that F is S measurable. So, ang pointwise limit ng mga measurable sequence of measurable functions remains measurable. Do you have a question with this? This is quite complicated, no? This is a little complicated. Kumbaga, yung measurability ng F was dictated or is dependent on the measurability of each Fn, no? Right? Okay. Can I continue? Can I continue? All right. So here we are now defining a particular notion in a measure space. If you have a measure space, and we're talking about a certain property, let's say property of a function, property of a set, whatever, kung ano mang property yun. A property P is said to hold almost everywhere. So you will hear this a lot of times, no, from your teacher in analysis, no. You will hear whenever we say this in analysis, almost everywhere, no, it's sometimes abbreviated as A dot E dot, okay, AE, almost everywhere. If there exists a measurable set E such that what? P holds for all X outside E and the measure of E is 0. So what does that say? Pag sinasabi mong nag-hold almost everywhere yung particular property, ibig sabihin, that doesn't mean nag-hold ka everywhere or for all X, no? Kailangan nag-hold yung property at least sa complement ng isang set na ang measure naman ay 0. Kumbaga, sa Tagalog, kung hindi man mag-hold si P sa X, kailangan yung set kung saan hindi siya nag-hold, kung sakali man hindi siya nag-hold, dapat ang measure lang nun ay 0. Kumbaga, walang bilang yung set kung saan siya hindi sakaling hindi nag-hold. Pero hindi ko sinasabing hindi nag-hold sa iha. Ang sinasabi ko, nag-hold siya doon sa complement ng E at ang E ay may measure na 0. Kaya kapag ang isang property nag-hold everywhere, nag-hold siya almost everywhere, but not conversely. Kasi hindi porket nag-hold ka almost everywhere, it doesn't mean na nag-hold ka everywhere. Okay? I will give you an example. Let's consider the Dirichlet function. The Dirichlet function on R is basically the characteristic function on Q. Anong meaning nito? Ang value niya, 1. No, ang value niyan ay 1 basta si x ay rational. Let me just abbreviate. And then 0 if x is irrational. Pag wala ka doon sa Q. Ganyan ang itsura ng Dirichlet function or the Dirichlet function. If you sabi ng teacher ko whichever kasi si Dirichlet once lived in Germany and once lived in France. Now when he was in Germany, it's Dirichlet. If you are in France, it's Dirichlet. So however you want to read it, it doesn't matter. If we're talking about the Lebesgue measure lambda ang pangalan natin sa Lebesgue measure sa subject natin, di ba? We can say that this function, the Dirichlet function, is 0 almost everywhere. Now, pag narinig nyo na 0 siya almost, di ba hindi naman siya laging 0? Kasi kung babalikan yung definition, kailan siya nagsi-0? Nagsi-0 siya sa lahat ng irrational number. Tapos, hindi siya 0. Saan lang siya hindi 0? Sa mga rational numbers. Gaano ba kalaki yung set of rational numbers? Countable yun. Kaya ang measure nun ay 0. Yun. That's exactly what we mean by almost everywhere. Kaya kapag nakarinig kayo ng phrase na si f ay 0 almost everywhere, it doesn't mean na it is constantly 0. It only means to say that kung sakali mang hindi siya 0, dapat doon lang yun sa isang set na ang measure ay 0. Kagaya nito. Saan nga ba hindi 0 yung f? Hindi lang naman siya 0 sa q. Nagkataon yung q ay may Lebesgue measure na 0. So, did you understand the logic of the phrase almost everywhere? Ano sinabi ng teacher mo? Your grade is 0 almost everywhere. Charot. Joke lang. Naintindihan niyo almost everywhere yung lohika niya. Kung merong mang set kung saan hindi siya nag-hold yung particular property na yun, kailangan yung set na yun hindi masyado malaki kasi ang measure niya dapat nire-require natin to be 0. Okay? Yeah. Balikan natin. If we're considering the Lebesgue measure, naalala nyo, kapag ang set ay measure 0, automatic measurable, Lebesgue measurable, ayan. I am being specific ha. Naalala nyo if a set is Lebesgue measurable, if a set has a Lebesgue measure of 0, it's measurable. Therefore, lahat ng subset ng isang set of measure 0 ay measure 0 rin. Therefore, lahat ng subset ng isang measure 0 set ay measurable. Lebesgue measurable, I'm sorry. I'm talking about Lebesgue measurable. It turns out that this property does not hold in any measure space. There are some measure space where itong set na ito ay measure 0 naman, no? Tapos pero meron siyang subset na wala siya doon sa sigma algebra of concern, no? Okay, kaya meron tayong ganitong definition. A measure space is said to be complete. So this is different from a complete metric space or whatever. You might or you might have heard this term before, but it has nothing to do with that, yung completeness before, no? So a measure space is complete if whenever a set is measurable and has a measure 0, then every subset of E is also measurable or is an element of S. Pag ang set mo measurable at ang measure niya ay 0, dapat lahat ng subset nun ay measurable din. Okay, yun ang sabihin natin ng complete. Kumbaga, very inclusive ang space na na complete, no? Measure 0 ka, measurable, measurable ka, tapos measure 0, lahat ng subset mo measurable din. Ganun ang complete. Meron ba, sir, example ng space na complete? Yes. If you consider the measure space R with M as the sigma algebra containing all the Lebesgue measurable sets for that matter, at yung lambda mo yung Lebesgue measure, then the space is complete. Kasi kapag ang set mo measure 0, sa space na to, pag ang set mo measure 0, automatic nga measurable siya, di ba? Di ba? Pagkatapos, dahil measurable siya, measure 0 siya, lahat ng subset nun, because it's smaller by monotonicity of lambda, if you can remember that, lahat ng subset niya, 0 lang din ang measure. But sabi ko nga, sa under the Lebesgue measure, pag 0 ang measure, automatic kasi measurable. Take note, that happens only in the Lebesgue space. No? In some other measure space, that might not be true. Sir, can you give me an example? Yes, I have an example for you. Hindi na tayo kailangang lumayo. Let's just take, papalitan ko na lang yung sigma algebra. I'm going to replace it by the sigma algebra of Borel sets in R. Okay? Yung beta dito is the Borel measure. Ang Borel measure, siya lang yung Lebesgue outer measure kapag ginagamit mo sa mga Borel sets. Ang Lebesgue measure, siya lang yung Lebesgue outer measure pag ginagamit mo sa mga Lebesgue measurable na sets. I do not get confused, although it's really confusing. I know. You know, this set is not complete. Why? Naalala niyo yung Cantor set? This is Borel. Yung Cantor set is Borel. Kasi intersection siya ng mga closed sets. If you can remember its construction. No? Katapos, ang measure niya, ang Lebesgue measure niya actually 0. So therefore, yung Borel measure niya ay 0. But can you remember yung set M? Yung set M dati, no? May subset siya. Sorry. K has a subset M. Okay? Which is not Borel. But actually, but is Lebesgue measurable. Si M yung example natin ng set na Lebesgue measurable naman pero hindi siya Borel. So nakita nyo, si K nandito sa B, di ba? Ang measure niya ay 0, pero may subset siya na M na hindi Borel set. So yung subset niya wala dito sa B. So therefore, this measure space is not complete or it cannot qualify as a complete measure space. Did you understand? Pakita nyo, no? Kahit yung example ng actually, ang mangyari, almost all almost all measure space, parang ano complete parang mahirap mag-construct ng hindi complete na measure space. Pero the thing is, mayroong example. Ayun, no? Yung Borel space. Yan. Ayun na nga. But K has a non-Borel subset M. The reason why we're talking about complete measure space, because there are certain results that the completeness is needed in order to prove. Okay? For example, ito. So in this theorem, si xi complete measure space. Requirement ang complete dito para mag-hold ito ha. Otherwise, hindi. So for example, mag-hold yung dalawang theorems na yan dito, pero hindi yan mag-work dito. Okay ba? Can I proceed? Can I proceed? Are you still there? Wala kayong questions? Okay. So these are the completeness sensitive result. When you say completeness sensitive results, kasi nag-hold lang sila just because the space is complete. Otherwise, they do not necessarily hold. No? So ano yung number one? If a function f is S measurable, and there is a function g which is equal to f almost everywhere, what does that mean? Halimbawa, ito si function na f, no? Tapos ito kunwari si function, alam ko si f measurable. Okay. Tapos kunwari itong red, ito yung function g. Not necessarily equal sila, but they are equal almost everywhere. So maybe ang itsura ng g ganito. Nakapatong siya sa f, tapos biglang may tatalon na ganyan. Tapos may butas ulit, ganyan. No? Ganyan. Yan si G, yung red. Nakita nyo, in this example, f is G. We cannot say that f is G. Kasi that's not, f of x is not g of x for all x. There are certain points, wait, what's this? There are certain points where f and g do not agree. For example, saan yung mga points na yun? Dito sa mga points na to, they do not agree, no? In fact, ang isang malaking pinagkaiba ni F at saka ni G, si F continuous, si G hindi. Na? But they are equal almost everywhere kasi kung meron mang set kung saan sila hindi nag-agree, ilang points lang yon? 3 points, finite. Therefore, ang measure nun ay 0. In terms of Lebesgue measure, ha? Siyempre, ang example ko, Lebesgue measure para may idea tayo. Maraming measure spaces na iba, pero ang interesting para sa subject natin yung Lebesgue measure. Okay? In fact, alam nyo ba, although si G ay hindi continuous, di ba? Obviously, from the picture, G is not continuous. But we can say that G is continuous almost everywhere. So pag sinabi kong continuous almost everywhere, kung meron mga points where it is not continuous, dapat kaunti lang yun. Kailangan ang measure nun ay 0 lang. So ano sabi nito? Result number 1 will further increase the number of examples that we have. Kasi, for example, you can just construct a continuous function. We know for a fact that's a Lebesgue measurable function. Tapos, gumawa ka ng mga discontinuities. Konti lang. As long as yung number of discontinuities ay, let's say, finite, okay, kung infinite man, countable, basta kailangan measure 0. The resulting function that you will construct out of it, no, is going to be measurable still. Hindi nawawala yung pagiging measurable if you deviate from a measurable function by a set with only measure 0. So, naiintindihan nyo? Did you understand result number 1? Ang importante dito, ang gusto ko dito, maintindihan niyo yung result more than sa alam niyo yung proof kasi the result is more important. So you can apply it somewhere. Okay? Number 2. Okay, so here's number 2. I want you to fix a measurable set E. Okay? Then according to the theorem number 2, si F ay measurable, S measurable, if and only if these two restrictions are S measurable. Ano yung sabihin ng restrictions? Ano yung sabihin ng notation na ito? Yung notation na ito, ano lang yan? Yung si F lang din siya, ang domain mo, pinapaliit mo lang sa E. So parang halimbawa, let me just clear this page for you. Ano ba ito si F? Okay. So ang domain ni F ay X. Kunwari yan yung X. Yung red ay si X. Now I will take a subset of X. I will shade it as violet. For example, ito si E. O yung E ay union ng dalawang intervals like so. No, yan yung E, si X. Nasaan yung restriction? So where is now the restriction of F in E? So anong itsura ng graph ng restriction ni F sa E? Basically, kokopyahin mo lang si F pero puputulin mo siya doon lang sa portion kung saan nasaan si E. So ganito siya. Yan. Tapos, yan. So yung restriction mo is restricted. Kaya nga restriction ang tawag. Yung green na function, yun yung F/E. No? Yun yung F bar E. Pambasa dyan, restriction of F on E. So basically, si F lang din siya. Only, we are just restricting it to the set E. Okay? Anong sabi ng result? Sabi ng result, the blue function will be measurable if and only if these two restrictions are measurable. Sabihin, kung yung restriction na ito, yung green, ay measurable, tsaka yung restriction dun sa complement na E. Nasaan yung complement ng E dito? So, dapat ito rin, measurable. Naintindihan nyo? Naintindihan nyo? Wala kayong tanong? Okay. Okay, so how do we write a proof for number 1 and number 2? Ganito. Ang bilis naman nito lumabas. Sige, ganito. Isusulat, tatawagin natin E, yung set of all X where, so number 1 tayo ha. Take note sa number 1 tayo. For number 1, so we will fix or we will write the set, we will define the set E to be the set of those points where F and G do not agree. Sa katotohanan yan, pwedeng empty yan. Pag nag-empty si E, sabihin yung F equal lang kay G. Pero kung may laman yan si E, hindi sila equal. Of course. Di ba? Okay. So what we want to do here, anong alam natin kay E? We know that this has measure 0. Ang laki naman ng pen ko. What do we know about E? This has measure 0. Kasi nga, F is G almost everywhere. Okay? Ano bang gusto natin ipakita? Kailangan natin ipakita na si G is also measurable. So, ang laging start ng proof, let A be in R. Ay, may mali dito. Sige nga, spot the wrong uh, portion. Ito, ang interest natin si G. Yun yung ipapakita nating ano, measurable. So, kukunin natin yung inverse image ng interval from A to infinity under the function G. Okay? Huwag niyo munang pansinin ito. Bakit siya nagkaganyan? I will explain. Sige. Ito yung X. Ito yung E. I hope I can explain this further. Ano yung nandun sa E? Nasa E, lahat ng mga points where F and G do not agree. Okay? If I take an arbitrary X from X, dalawa yung pwedeng mangyari. Pwedeng nasa E ka, pwedeng wala ka sa E. Now, pwedeng nandito ka, or pwedeng nandito ka. Okay? Kapag si X ay nasa E, ano ngayon? Ibig sabihin, magkaiba si F at si G. Pag si little x ay nandito sa complement ng E, ibig sabihin, what does that mean? Equal lang si F at G. Do you understand? Now look at this. Charot. How do you interpret this one? Kasi ganito yan. Takpan nyo muna to. Pag kumuha ka ng x sa kaliwa, kuha ka ng x dito sa kaliwa, meron kang g of x that is greater than a. Na? Pero yung g of x na yun, dalawang possibility. Pag nandito ka sa a, saan equal yung g of x? Pag nandito ka sa sa e, mali. Pag nandito ka sa complement ng e, si g of x parehas lang sa f of x. Kaya yung inverse image na to, I can replace that by f inverse. Kasi technically, in this set, parehas lang yung f at saka yung g. Pero on this set, I have to maintain g. Kumbaga, ito yung mga points where g of x is greater than a. Okay. Ito yung mga points where g of x is greater than a pero nasa e. Ito naman yung mga points where g of x is greater than a na wala sa e. Intindihan nyo? Pero doon sa mga points na wala ka sa e, ang g of x kasi parehas lang sa f of x. Kaya parehas lang yung g inverse of a infinity sa f inverse of a infinity kasi nandito ka sa complement ng e. So do you get this? Why this is a union? Kasi dalawang cases yan, or, no? Itong intersection end yan. Kasi sinasabi na ito, ang g of x mo greater than a, at the same time yung x mo nasa e. Okay. Question, bakit ngayon ito nasa S? Bakit ang conclusion nasa S, no? Let me explain. Etong intersection yan, subset yan ng E. Di ba? Ang E intersection B, lagi yung subset ng B. Okay? Si E ay may measure na 0. Kasi nga F and G are equal almost everywhere. Kaya kung mangyayari man to, kaunti lang yun. So this set is a subset of a set E, which is measurable. No? Tapos, ang measure ay 0. Pagkatapos, dahil si X ay complete measure space, lahat ng subset ng E dapat measurable. So, nasaan siya? Ito dapat nasa S. Kasi si X ay complete. Doon na pumasok yung pagiging complete. Ito naman, si F na nga kasi ay given to be measurable. So, kahit na ito yung F inverse, ito yung nasa S. Ang E nasa S. Kaya ito ay nasa S. Okay? Bakit measurable si E? By definition, pag, if whenever E is in S, so required na si E ay nasa S for your information. Kaya ito ay nasa S. So, ang union ng dalawang bagay na nasa S should be another element of S. So, that shows that G must also be S measurable. Actually, the same will go for number 2. Ganyan din halos yung logic, except wala na tayong pinapalitan. Ang gagawin na lang natin, iba yung E dito sa number 1. Take note, iba yung E dito sa number 1, iba yung E dito sa number 2. E here is just a fixed measurable set. Ito kasing mga points where f of x is greater than a may be grouped into 2. Ito yung mga points where f of x is greater than a at the same time nasa E. Ito naman yung mga points whose f of x is greater than a but yung x wala sa E. Ayan, kaya yun. Did you understand? Ito ngayon ay nasa S kasi subset, kasi, si F ay measurable, si E ay measurable, therefore yung intersection na to measurable. Si F ay measurable, so itong inverse image na to measurable, nasa S. Ang complement ng E is also measurable, so ito yung nasa S. Kaya lahat yan nasa S. Did you understand me? So, basta, kung nalilito kayo sa proof, just remember these results. Okay? Yan. So, we have the following corollary. So, corollary na ito, may nakalimutan ako i-type. Yung x dito has to be complete. Sabihin lahat ng mga sets na measure 0, tas measurable, dapat lahat ng subset nun ay, kailangan lahat ng subset nun ay measurable din. Naalala nyo kanina, ang pointwise limit ng, sequence of measurable functions is, what? Still measurable. In fact, the corollary strengthens that result. Except, kailangan nga lang, yung space ay complete. Sabi ng result, you don't even need to converge pointwise. Ang kailangan lang mag-converge ka almost everywhere. You see? You don't even need to converge pointwise. Kasi pag pointwise, for all x yun. Ang convergence nangyayari for all x. The convergence only need to happen almost everywhere. Kung lahat ito ay measurable, yung limit mo is also measurable so long as the space is a complete measurable space. Did you understand? Bakit hindi ko na kailangang i-prove ito? Kasi nga, pwede mo namang itapon lang yung without loss of generality, you may just assume that Fn converges pointwise. Kasi kung mayroong mang portion yung space where Fn does not converge to F, ano lang yun? Measure 0 lang yun. And it doesn't contribute to the result. Parang ganun yung idea nito. So you don't need to bother. I-consider mo lang ulit yung portion ng space where Fn converges to F at the same time nandoon sa E. At the same time, i-consider mo rin yung part ng space kung saan hindi nagko-converge yung mali. Hatiin mo yung x sa dalawang part. Yung unang part, consider mo yung mga points where, Fn does not converge to F. Ang idea, maliit lang to, measure 0. And because of the completeness, ito ay measurable. Parang ganon. Dito naman, nagko-converge naman uniformly si Fn kay F. Kaya, uniformly, pointwise dun sa x minus E. Kaya, ang, yung convergence is guaranteed. Tapos gagamitin mo yung number 2. Okay? There. I don't need to write the proof anymore. Okay. Hinga muna tayo. So the next types of functions which will be helpful for us, especially next meeting, yung definition ng Lebesgue integral, are those functions which are called simple functions. So real analysis, kapag sinabing ang function ay simple, it's a type of a measurable function where it only has finitely many values. No, parang yung mga characteristic function, 0 at 1 lang ang value, dalawa lang ang value. In general, pag sinabing simple, kahit na ilan ang value, basta finite. Pangalawa, dapat siya ay measurable. So sabihin natin, for example, si S ay simple. So sabi nga natin, meron siyang finitely many values. Kunwari yung mga values na yun ay C1, C2 hanggang Cn. So I've listed them here. The distinct values of S. Okay. Ang gagawin ko ngayon, isusulat ko as EK yung inverse image ng singleton na CK. Ang laman nun, those are the points in the space where the image is exactly CK. Finite lang naman ang values mo, no? So ang gawin mo, ang laman ng E1, lahat ng mga nagpupunta sa C1, ang laman ng E2, lahat ng mga points na ang value ng S ay C2. Parang sinesegregate mo yung space into N parts, no? Yung unang part, parang ganito, ito yung X. Ang mangyayari dyan ganito eh. Ito yung E1, E2, E3, E4, E5. Kunwari, yung mga nasa E1, ito yung mga may value na C1. No? Pag kumuha ng X dito, in-apply mo si S, C1 yan. Pag kumuha ng X dito sa E2, in-apply mo si S, C2 ang lalabas na value. And so on. So, ginugrupo mo lang yung mga points ng X into portions. No? That's the idea. Then, you may express S as a linear combination of characteristic functions. Now, it's actually C1 chi E1 plus C2 chi E2 plus and so on plus Cn chi En. Why is this representation correct? Kasi pag may kumuha ng arbitrary X, no? Yung X mo, matatagpuan mo sa isang EK for some unique K in the list, di ba? Tama ba? Halimbawa, nandito ka sa wag na dyan sa E4. Kung nandito ka sa E1, pag nasa E1 ka, wala ka dun sa iba. In short, yung mga characteristics na functions na to, kaya characteristic function ang ginamit, parang light switch yan eh. 0 or 1 lang sila. Pag nasa E1 siya, 1 siya. Tapos all the others are 0. Kaya anong value ng S pag nasa E1? C1 kasi C1 times 1. O halimbawa yung X mo napunta sa E2, 0 naman ito naman ang 1. 0 lang yung iba. Kaya anong value ng S? C2. Did you understand? So, naintindihan ba si Sir? Pag si X ay nasa E3, si Chi E3 naman ang 1, all the other Chi's are 0. Kaya ganyan yung representation. Naintindihan niyo si Sir? Parang light switch. Huh? Pag 1 yung isa, all the others will be zeros. Okay. Ang tawag natin dito ay yung canonical representation of S. Yung word na canonical, you will hear this in mathematics a number of times, ang ibig sabihin lang naman ng canonical representation, standard form, parang ganun siya, di ba? Sa elementary algebra, standard form of an equation. Kaya pag nasa higher mathematics ka, we use the word canonical more often than the word standard. Kasi yung word na standard, parang ano siya, hindi siya technical, parang, I don't know. Basta ganun yung idea. I have an example over here. So, for example, this is a function in R, no? Sa real number line tayo, which is an example of a simple function. Paano ko nasabing simple function to? Kasi when you look at the range of this function, yung values niya, 5 lang, no? Ito yung isa. Ay, 4 lang pala. Ito yung pangalawa. Ito yung pangatlong value. Ito yung pang-apat na value. May 4 lang na values yung function mo. So, kung ililista mo yung 4 na values na yun, yan. C1, C2, C3, C4. Ay, ba't naging C2 to? 4 yan ha. Please correct that this is a 4. Nasaan yung E1? Ang E1 is the set of all points X na ang value ay C1. No? Paano mo malalaman? Ito yun. Yung E1 yung olive color. No? Kasi kapag nandito ka, ang value ng S of X mo, C1. Di ba? Kahit na nandito ka. Right? So yung olive color na set dun sa domain, yun yung E1. Nasa naman yung E2. Ayan yung E2. Kasi pag nandito ka, di ba? Pupunta ka sa C2. Ito yung E3. At ito yung E4. As you can see, in the end, no, na-partition mo yung domain into 4 parts. Yung mga nasa E1, yung mga nasa E2, yung mga nasa E3, at saka yung mga nasa E4. So, therefore, we can write as simply as C1 kay E1 plus C2 kay E2 plus C3 kay E3, C4 kay E4. Naintindihan nyo? Kapag kayo nasa probability theory, anong tawag nyo sa S? Ito yung mga tinatawag yung discrete random variable. Ayun yung ating, I mean, yung parang corresponding idea. Halimbawa, pag nag-throw ka ng die, random, let's say balanced die. Okay? Tapos kunwari, yung random variable X mo ay yung result when you throw a die. Ang possible values nun, 6 lang. 1, 2, 3, 4, 5, 6. Diba? Naintindihan nyo? Okay. So pag sinulat na halimbawa 4 kay 01 plus 3 kay kailangan disjoint itong mga sets na ito. 1, 2 minus kay 2 infinity. What does this mean? Pag nakita nyo ito na sinulat ko, punta nga tayo sa Scratch. Oh, ano yung tsura ng graph nito? Pag nakita nyo itong sinulat ko sa board, okay, if this is the x-axis, the y-axis, no? Nasaan na yung interval na 0, 1? So, ito yung interval na 0, 1. 1, 2, 3, 4. So, ano yung itsura ng graph niya? Ang itsura ng graph niya, 4 ang value niya sa 0, 1. So, parang ganyan siya, no? 4, 0, 1. Pero dito, open. Kasi hindi kasama yung 1 doon sa teritoryo ng unang term, no? Yung second term mo, 3 kay 1, 2. 3 ang value niya sa 1, 2. Okay? Ay, sumobra ng konti. Tapos, sa 2 to infinity, ang value niya ay, ano yung sabihin ng minus? Negative 1. So, bababa tayo dito. Negative 1. Mula dito sa 2, papunta ng infinity. Oh, how about in all other points? In all other points, it is just 0. No? Kasi pag lahat ito off, 0 lang yung value ng S. So this is an example of a simple function. Naintindihan nyo ba? Naintindihan nyo yung example na ito? Naintindihan nyo si Sir? Ito yung pinakamadaling intindihin sa lesson natin. Di ba? Ang tanong ko dito, anuhin natin yung mga simple functions na to. Bakit bigla na lang nag-discuss si Sir ng simple functions? Yung mga simple functions na to, ito yung gagawin nating rectangles later. Ano yung rectangles? Ganyan, no? Okay? Yung pinang-approximate nyo ng integral. Naalala niyo yan? Gagamitin natin yung mga simple functions to represent the rectangles that we do in elementary mathematics to estimate the area under a curve. Halimbawa, paano mo malalaman yung total integral ni S? Ang ginagawa natin to get the integral later, no? So this is what we do. Pag nakita nyo ito, no? Ang ginagawa natin dyan, 4 times yung measure ng interval plus 3 times what? The measure of the interval 1, 2 minus 1 times the measure of the interval 2 to infinity. Did you understand? Ganyan. Kasi yung measure, parang mini-measure mo kung ano yung length nito times yung height. Parang width times height plus width times height plus width times height. Ganun lang ulit. Did you understand? That's how we will define this integral. Eh sir, paano yung mga function na hindi simple? Paano mo i-integrate? No? So that's the question. Kaya meron tayo ng susunod na result. Ang sabi nito, kahit na anong measurable function may be approximated by a simple function from below and a simple function from above. No? Anong ibig sabihin nun? So to be more specific, if you get a measurable, actually a bounded measurable function, f, no? So parang ito yung f. Let me just draw it for you. According to the theorem, for every epsilon greater than 0, there exists simple function phi epsilon and psi epsilon so that f is squeezed between phi epsilon and psi epsilon, and the distance between phi epsilon and psi epsilon is less than epsilon for all x. Now, how sa picture ko, nasaan yung phi epsilon, nasaan yung psi epsilon, I will show you where. Kunwari, ito yung f. Measurable siya kunwari. Saan yung makikita yung phi epsilon tsaka psi epsilon? Ang gawin nyo, drawing ko to. Ito kunwari si f plus epsilon over 2. Ito naman kunwari si f minus epsilon over 2. Next meeting, ipapakita natin kung paano mag-construct ng phi epsilon tsaka psi epsilon. Ano ba yung phi epsilon? Yung phi epsilon dyan parang ito. Yung phi yung nasa ilalim. Parang ganyan yan. Oh, naintindihan nyo? Yan yung phi epsilon. Yung psi epsilon nasa taas. Ganyan naman siya. Yan. Ganyan ang tsura ng psi epsilon. Nakita nyo yung phi epsilon tsaka psi epsilon are simple functions. No? They squeeze f in between. Their distance cannot be is less than epsilon for all x. Anuhin natin yung mga simple functions na yan. Yan yung gagamitin natin pang approximate dun sa area under the curves later. No? Intindihan nyo? Meron kang overestimation tsaka underestimation. Just like the Riemann integral. Nagmumukha lang siyang Riemann integral kasi ang dinadrawing kong function mga continuous na functions. But if the function is quite complicated, the simple functions will be complicated as well. Mukha lang siyang pareha sa Riemann integral kasi yung mga functions nga na dinadrawing ko are nicely drawn. Okay? We will not be proving it today. Maybe next time. No? Kasi we don't have enough time. It's already 12 o'clock there. So let me now stop the recording.